So first thing I want to look at today is this thing called critical points. Basically, it's one of these two situations. The derivative is 0 or undefined. Now, equals 0, we know a stationary point. So it's like a stationary point is a critical point, but we call them stationary points. I guess it's a bit like a square is a rectangle, but we call it a square. All right, so some pictures here to illustrate. So there's a typical polynomial. Maximum turning points, well, they would be critical points. Minimum turning points, they would be critical points, because they're when the derivative is equal to 0. Then we have our cubic, what we call a horizontal point of inflection there. Because it's a horizontal point of inflection, the derivative is equal to 0, so that would be a critical point. Parabola on its side. Well, at the vertex of this one, you've got a vertical tangent. So the derivative is undefined. That would be a critical point. You've got these sorts of shapes. It's what we call a cusp. Now, that is still a minimum point, but there the derivative is undefined. Because in order for the derivative to be defined, the curve must be what we call smooth continuous. So it is continuous, it's just not smooth. It's got a sharp point to it. Voila.